my name is Anna. Today I'm conducting an experiment on limiting reactant. So the purpose of this experiment is to find the limiting reagent when sodium bicarbonate reacts with acetic acid. The balanced chemical reaction is sodium bicarbonate reacting with acetic acid to produce sodium acetate, water, and carbon dioxide. I have all of my materials here. Each bottle contains 100 milliliters of vinegar. Balloon number 1 contains 1/4 teaspoon of baking soda. Balloon number 2 has 3/4 teaspoons. Balloon number 3 has 1.5 teaspoons. And balloon number 4 has 3 teaspoons of baking soda. Let's get started. So here we can see that the balloon with only 1/4 teaspoon of baking soda is actually grown to be the smallest. The one with 3 teaspoons of baking soda has expanded to be the largest. So the carbonic acid in each reaction from sodium bicarbonate, and acetic acid is unstable, so it undergoes decomposition to produce water, H2O, and carbon dioxide, CO2. The carbon dioxide is then released as bubbles to expand each balloon.
So for the first 3 reactions, balloon 1, 2, and 3, I know that the limiting reactant is sodium bicarbonate or baking soda. The amount of baking soda is the only element that changes each time and causes the reaction to differ. But in balloon number 4, I know that the limiting reactant is vinegar because there was an excess amount of sodium bicarbonate showing at the bottom of the bottle. This shows that the vinegar was used up before the reaction had completely finished. Now, the reaction with the maximum amount of carbon dioxide produced was balloon number 3 and balloon number 4. If there was a 5th balloon with 100 milliliters of vinegar and 6 teaspoons of baking soda, the reaction would be very similar to balloon number 4 here. There'd still be an excess amount of sodium bicarbonate and the same amount of product would still be produced. Now, if there was another balloon with 200 milliliters of vinegar, but 3 teaspoons of baking soda, there would be more product of carbon dioxide produced as the baking soda is no longer the excess reactant. I have my calculations here. So this question was asking me to find how many moles of carbon dioxide can be produced when they give me 100 grams of vinegar and 1.2 grams of baking soda. Here I have 1.2 grams of baking soda or sodium bicarbonate. To convert that into moles, I have to divide the 1 mole by its molar mass, 8.399 6 grams of sodium bicarbonate. I then have to multiply that by the mole of carbon dioxide and divide that by the sodium bicarbonate. These two cancel out right here. The grams of sodium bicarbonate cancel out. 1.25 times divided by 83.996 times 1 will give me 0.0149 moles of carbon dioxide. To find the amount of moles produced in the reactant of vinegar or acetic acid, 100 grams of acetic acid or vinegar times its mole divided by its molar mass, 60.032 grams, times a mole of carbon dioxide divided by the whole mole of the entire reactant here. The grams cancel out these two. 100 grams divided by 60, 0.32 times 1 will give me 1.665 moles of carbon dioxide. Now here it's asking me what is the limiting reagent. Using these calculations here, I can see that the limiting reagent is this one, sodium bicarbonate, which was baking soda. Number 2 asks me to calculate the theoretical yield for this reaction if I have 10 grams of sodium bicarbonate reacting with acetic acid, then was creating carbon dioxide, 111.88 grams of carbon dioxide collected. So here I have my 10 grams of baking soda sodium bicarbonate, multiply that by the mole of sodium bicarbonate to cancel out, to convert it from grams to moles. 8.399 is the molar mass, as we know from up here as well. You multiply that by the moles, these two will cancel out. So you're trying to get that into grams again, but grams of carbon dioxide. And then multiply the grams, the molar mass of carbon dioxide to get the full grams of carbon dioxide. So these two cancels out. 10 grams divided by 83.996 grams times 1. These two cancel out, times 43.999 grams of carbon dioxide. This will give me 5.238 grams of carbon dioxide as my theoretical yield. Thank you. That concludes my experiment.